Okay, and now we're doing together handout about reactions and equations. So a chemical reaction is a process in which a substance or substances changes into one or more new substances. It's like baking, it's like cooking, right? This picture shows us that out of 2 glasses of milk and how many? 7 eggs, you can have cookies, right? So that is cooking, and chemical reactions are cooking in a special way, right? So, and you already know, because we mentioned it before, you already know that conservation of matter law that shows us that matter still the same. So how many atoms do you have at the beginning? And you will end up with the same amount of atoms, right? And the graphical way to show this conservation of matter law is writing chemical equations and balance them. And I'm just going to remind you guys what are what types of numbers we are using in balancing chemical equations. So the first of all, big numbers in front the formulas. For example, let me give you an example. Let's say uh, 8 2s plus O2 gives us SO2 plus H2O, right? So, and we need to balance it. So 2 goes here, 2, 2, and 3 goes here, right? So, and these big numbers like 2, I'm going to underline it 3, 2, and 2 are coefficients. So they are coefficients. They shows us, they apply for the entire compound. They shows us how many particles of compound we have here. So these are actually sign 2HS 8 2s is the same like H2s one time and 8 2s the second time, right? This sign, this 302, 302, it's the same like O2 one time, O2 second time, and O2 the third time, right? So coefficients apply to the entire compound. Subscript. Subscript are small numbers to the right side of elements symbols, right? So and they apply only to the element, only to the atom that they are behind. So for example, in this case, in this scenario, so H2S gives us 2 atoms of hydrogen, right? Because H2 and 1 atom of sulfur. Why 1? There is no subscript here. Yes, when there is no, they mean 1. Okay, so and this scheme shows you the difference between subscript, right? Written smaller than chemical symbol, so it will not correct to write like this, right? No, that's not correct. So this is the way. H and smaller, lower, H2O. this is subscript. But coefficient, the same size as the chemical symbol, 2. Or maybe a little bit bigger. Okay. So let's do some concept checking. We need to count atoms in the following compounds. So compound P4O10, and I'm going to name them just to help you remember how to name compounds, right? So P4O10, it's covalent compound because both of their elements are non-metals. So it's tetraphosphorus decoxide, right? So how many atoms of phosphorus is here? 4. Why? Because there is subscript 4 here. 10. No calcium here, right? The difference is between the first and the second formula is that the second has a coefficient that actually changes numbers of atoms. For 2p4O10, it will be 2 times more atoms than it was before. So 2 times more phosphorus, that gives us 8, and 2 times more oxygen gives us 20, right? So 5, calcium oxide. This is a ionic compound because calcium is a metal and oxygen is a non-metal, so that is calcium oxide. Let's start with just calcium O. No subscript here, right? So that means that in one unit is only one atom of calcium and another atom of oxygen. But coefficient 5 gives us 5 multiplied by 1 calcium. Oh, I'm sorry, not in this case. 5 multiplied by 1, 5 atoms of calcium, right? And 5 multiplied by 1, 5 atoms of oxygen, right? The next one, the next one, calcium phosphate. Ionic compound too. It's a type of salt, calcium phosphate. So this small subscript here, calcium 3, shows us that we have 3 calcium atoms here. So 3 for calcium, right? PO4 2 times. And see, there are parentheses here and a small subscript to the right side of the parentheses. So that gives us phosphorus 1 here, right? Because we don't need to write if it's just one atom, but 2 times 1 multiplied by 2 phosphorus, right? So PO4 2 times gives us PO4 and PO4. That is exactly the same like PO4 2 times, right? So you can see that there are 2 phosphorus here. How many oxygen? In this way, you can see clearly that 4 and 4 gives us 8, right? Or we can do like 2 times by 4, 8 oxygen here. So you need just multiply these subscripts here. And 3, additional coefficient in front of triple all amounts of atoms here. So for phosphorus, it will not be 2 anymore. It will be 3 times bigger. 3 times 2, 6. For oxygen, it will not be 8 anymore. It will be 3 times bigger. So 24. And for calcium, it will be 3 times bigger also. So it's 9, right? Okay, so concept checking, we finished it, right? And now you do practice problems, set one, by yourself. Just one molecular of P2O5 means exactly the same like P2O5, right? Three molecules of P2O5, it's like 3 in front of the formula P2O5. So I think you got the idea. So 4 P2O5. I can give you just one example, right? So for phosphorus, P2O5 1. Molecular subscript shows us that for phosphorus is 2 atoms here, right? So 2 phosphorus here. But when we have 3 molecules or 3 P2O5, if you use the coefficient 3 in front of molecules instead of saying just 3 molecules of P2O5, you need triple the number of phosphorus. 3 multiplied by 2, 6 phosphorus. Okay? And here, 4 molecules of P2O5 gives us 4 times larger the number of phosphorus. So, but you multiply these 2 in one molecular, right? And 4 because 4 molecules you have, so 8. Okay, so and the rest of all, the rest of you will do by yourself, okay? So next unit, chemical reactions and chemical equations. So chemical reaction is a process in which a substance is changed into new substance, right? When out of reactants, new product formed, right? So we can tell about what is happening in our chemical reaction by words, like for this one. Nitrogen reacts with hydrogen and ammonia is being formed, right? But we use special chemical way to tell to say about to tell about this reaction. We use symbols and subscripts and coefficients to tell you what is happening here, right? So I already mentioned it, just I'm repeating that, but these symbols plus shows us that reactants or products are at the same time in this reaction. For example, N2 plus 3H2 this plus shows us that nitrogen reacts with hydrogen, right? Or, for example, in these reactions, HNO3 gives us NO2 plus oxygen plus water, right? 4 goes here, 4 goes here, 2, I think we balance. Yeah, it is balanced. So, and you can see only one reactant in this reaction, right? But 3 products. Nitrogen dioxide, oxygen, diatomic gas, and water. And there are pluses between them. That means that at this reaction, they are formed together. So at the same time, we get nitrogen dioxide, oxygen, and water. Okay? This yields Or it can be like this sign. Separates reactants from products. So separates equation of for the left and right side, and the left side uh, um, consists of reactants, and the right side has products. Okay, this symbol. um I'm not sure that we will mention this in this course of chemistry, but for somebody of you who is going to take another classes, chemistry classes, you will meet this symbol. So this symbol has has multiple meanings. So the first of all, it separates reactants from products, right? And it shows that this reaction is reversible. For some reason, it can react in a both way. So these symbols show us states like solid, liquid, or gaseous state, right? And this AQ or symbol shows us that our compound is dissolved in water. Okay, okay. We talked about this a lot, the law of conservation of mass, or the law of conservation, I'm sorry, of matter, right? And there are some rules written for you. Please just remember it, that you never change the subscript for the formulas. For example, if you need to balance equation, right? Like this, SO2 plus O2 gives us SO3, right? And if we balance this equation, we have one sulfur at the left side and one sulfur at the right side, right? And for oxygen, and we do not do this, right? No, that is not the way. You never change subscripts because formulas are given to you. You cannot change subscripts. You can only add special coefficients in front of molecules, okay? And these are some examples. Let's do concept checking. Balance the equation of chemical reaction. So, left side are reactants, right side are products, right? So, we start with hydrogen, right? H2 gives us two hydrogen, right? And H2O gives us two hydrogen too. So we can write it down like this. Two hydrogen, right? And two hydrogen here. Okay. But although their hydrogen is balanced, the oxygen is not, and you can see it, right? So oxygen, there are two atoms here, and only one is here. Okay, two hydrogens here, and only one oxygen is here. I'm sorry. So it's not balanced. We need to balance it, and the way we need to add coefficient, right? Coefficient 2 in front of H2O. That gives us 1 and 1 oxygen, right? Because these uh, how to say, this writing shows us that 2H2O gives us H2O, one time and H2O another time. And you can see one oxygen and one oxygen. But you do not do this. So if you have H2O and you need double amount of oxygen, you do not do this. You don't change subscript, right? Okay. So when we put coefficient 2 in front of water, the amount of oxygen changed, right? But at the same time, the amount of hydrogen changed. So now it's not 2, it's 2 times 2, 4 hydrogen here, right? But still 2 at the left side. But we need it to be 4. That's why I'm adding coefficient 2 in front of hydrogen, right? And recount atoms. 2H2 gives us 4 hydrogen. Okay. O2, 2 oxygen. Perfect. 2H2O gives us 4 hydrogen and 2 oxygen. So the equation is balance. Balance the equation. Magnesium plus O2 gives us magnesium oxide. So it's not balanced yet. We start with metal. Nothing is in front of magnesium. That means only one atom and one magnesium here and one magnesium is at the right side. We're good with magnesium, right? O2 gives us 2 oxygen and 1 oxygen here. And you see it's not balanced. We need 2 here. The way to do it, double coefficient, right? In front of magnesium, there is none for now, but we need it to be doubled. I mean, if it's non-written, we know that this is 1 here, right? We need it doubled, so I put 2 here. That gives us 2 multiply by 1, 2 magnesium atoms and 2 oxygen atoms, right? So you know that you can see that we're good to go with oxygen, but magnesium needs another coefficient too. And by recounting atoms, you are sure that your equation is balanced. So the next one, N2O, 2N, 1 oxygen here, 2N, and 2 oxygen here, right? And you can see oxygen is not balanced, right? 1 and 2 here. We need additional 2 in front of N2O. That gives us 2 multiplied by 2 and 2 multiplied by 1. So 4 nitrogen and 2 oxygen, right? So we're good with oxygen, okay, but we're not good with nitrogen. It's only 2 here. So we need to put 2 in front of nitrogen, okay? And recount atoms. Don't forget to recount atoms. Okay. NaI and chlorine reacts, so sodium iodide reacts with chlorine gas and gives us sodium chloride, table salt, and iodine, right? So 1 sodium, 1 iodine, 2 chlorine, 1 sodium, 1 chlorine, 2 iodine. And you can see chlorine and iodine are not balanced, so we just balance them. 2 here gives us mm, I'm doing this 2 and 2, right? And 2 goes here, that gives us 2 times more 2. and now you can see your equation is balanced. Okay. Next one, COO2, one carbon, one oxygen, and two oxygens here. One carbon, two oxygens, right? So carbon is balanced, three oxygen here and two oxygen here. And I add this coefficient to in front of CO because I need to double the amount of oxygen to be able to put the whole coefficients in front of, right? That gives us 2 and 2. Now we have two carbon at the left, one carbon at the right. So 2 goes here. That changes the amount of atoms like this. Two carbons, four oxygen, right? And four oxygen at the left side. Okay. The next one, CH C8 H18. So 8 carbon, 18 hydrogens, right? 2 oxygen, 1 carbon, 2 oxygen, and here is 2 hydrogen and 1 oxygen. And you already can see that, but maybe you will not see at the first sight. Okay, we will start with carbon. So 8 carbons here gives us coefficient 8 in front of CO2. That changes the amount of carbons C8, and 8 times more oxygen gives us 16, right? Okay. The next one, 18 hydrogens, and 2 hydrogens here gives us 9 in front of water. So 9 times more, 18, and 9 oxygen here, right? And as you can see, we have 16 plus 9 amounts of oxygen, so it's 25, right? And I cannot divide 25 by 2 and get a whole number. And the way is just doubled or double all our coefficients. So I am doing this. I will be using the different color to make it more not noticeable. Okay, so 2 goes in front of C2 CH C8 H18 and gives us 16 carbons and 36 hydrogen, correct? And not 8 CO2, right? I will use another coefficient, 16, gives us 16 carbons. And not 16 oxygen will be in this compound, but 32, 2 times more, right? And 36 hydrogen gives us 18 in front of water. So 2 times more, 36 hydrogen. We're good to go with hydrogen. And 2 times more oxygen, 18 oxygens atom, right? So, and together 32 plus 18 gives us how many? 50, right? And 50, we need 50. How do we get 50? 50 divided by 2 gives us 25. See, these rules help you to balance equations. The next one, C2, um, C2H6O. plus O2. So 2 carbons, 6 hydrogens, 1 oxygen here, right? 2 oxygen here, and 1 carbon, 2 oxygen, and 2 hydrogen, and 1 oxygen here. Okay, so the first of all, I'm going to balance carbon. So 2 carbons at the left. We need 2 here, and we'll get 2 carbons at the right, and double amount of oxygen, 4, right? Good. 6 hydrogen, and hydrogens are only in water, so we have 2 of them for now. Additional coefficient will be 3, so 3 times 2 gives us 6 hydrogens, right? So good. Okay, we're good with. And it's automatically changed the amount of oxygen, 3. So in total, the amount of oxygen will be 7, 4 and 3, 7. And we can't put any coefficient in front of C2H6O for now, because if we do, we will change amount of carbons and hydrogens, right? But we don't need to. That's why I'm just staying with 1 oxygen, okay, and trying to understand how many oxygen do I need more. I mean, I have 1 and I need 7. How many I need to add? 1 plus what? 1 plus 6, correct? So I need 6 oxygen here to get 7 at the left side. So and 6 divided by 2 gives us 3. Okay, and when you recount, you will be sure that you balance this equation. So, but these two were tough. I can tell you, yeah, they were tough. But if you rewatch the video and try to do it by yourself without watching it, you will have more understanding in this. Okay. So the next one, I'm just erase something. Okay. So the next one, calcium chloride aquatic, as you can see, so this is a solution, reacts with silver nitrate solution too, and we have silver chloride is solid, that means it precipitates from the solution, right? And calcium nitrate in the solution, inside the solution, okay? So, and metal, non-metal, non-metal, then hydrogen and oxygen if you have. So, we start with metal. Calcium, one calcium, right? Or you can write it down, one calcium. Then another metal, one silver, another silver, right? Okay. Non-metals, 2 chloride, then 1 chloride. Okay, we found it, right? 2 chloride, 1 chloride. We need 2 here, correct? Yes. And the amount of chloride is being changed for 2 and 2 here, right? So, and we jump here, 1 silver, but we need 2. 2 gives us necessarily to put a coefficient 2 in front of silver nitrate, right? Okay, and let's start from the beginning, right? I'm going to recount it. Okay, so calcium 1, chloride 2, 2 silver, 2 nitrogen, and 6 oxygen, right? 2 silver, 2 chlorine, 1 calcium, 2 nitrogen, and 6 oxygen. Are we good? Yes, it is completely balanced. Okay, and the next one, the last one here. So chlorine gas reacts with potassium bromide, and bromine is being formed, and potassium chloride, right? So 2 chlorine here, it's 2. Very strange, but it's 2. Okay, 1 potassium, 1 bromine, 2 bromine, 1 sodium, 1 chlorine. Okay, 2 chlorine here, 1 chlorine here, additional coefficient 2. 2 potassium, 2 chlorine, it's now here. We good with chlorine, right? But not good with potassium. It's only 1 here. We need a 2. So 2 goes here, 2, 2. And you can see everything is balanced. Okay. Please pay attention to details and don't be in a rush. Be attentive and you will succeed in balancing chemical equation. Okay, the next one, the question is, why must a chemical equation be balanced with respect to the law of conservation of matter? For example, why must this equation be written like this? And we can jump here, right? Atoms cannot be created, destroyed, or changed, only rearranged into different combinations. That means that the amount of atoms stay the same if we have uh, 2 hydrogens here, we need to have the same amount here. Yes, and it is the same. But what about oxygen in this way to write this equation? It's not balanced, so that means that we lost 1 oxygen, and this cannot happen, right? So that's why we balance equations to show that there is a conservation of matter law exists in the nature. Okay. Uh, the next topic is types of chemical reactions. So 5 of them: combination, decomposition, replacement, single and double replacement, combustion, and redox. Not in this unit we are going to talk about redox reactions. We are going to talk about them later. Итак, I'm sorry, a little bit of Russian, but okay. Combination reactions. 2 or more reactants gives us one product, right? Decomposition reactions. 1 reactant gives us 2 or more products. Okay, decomposition of carbonic and sulfurous acids. So you need to memorize these reactions because these acids are not stable, and when they form, they usually they decompose by themselves. So carbonic acids decompose to two oxides, I mean water. This is oxide of hydrogen, right? Or just water. And carbon dioxide. And it is balanced already. And the same way sulfurous acid decomposes. H2O plus SO2, sulfur dioxide.